Right, the next thing to do is to measure the plate current on each of the output tubes and make sure that the amp is correctly biased. We don't want the amp running at more than approximately 70% of the maximum plate dissipation of the 6L6s. Fender had a habit of biasing their amps a little bit hot, so we're just going to double check this and make sure that they are correct and adjust if need be. So there's a couple of ways of doing it. Find my little pointer thing. Here we go. The way I like to do it, and has always worked well for me, is to use the output transformer measurement. So essentially what that involves is measuring across the output transformer the resistance of each half of the primary section of the transformer. So essentially you go from the center tap, and a handy point to take that from is either right here or from the standby switch, because that's where the B plus is fed directly to the output transformer, this little red wire here, and from there to the plates on the tubes. And you can see I've got a probe here on this plate. So what we're doing essentially is measuring the resistance across each side of the output transformer, and once we've done that, we'll power the amp up. We'll then measure in the same points the voltage drop across the primary of the transformer, or at least each half of the primary, and that way then, using Ohm's law, we can actually work out what the current being drawn by the tubes actually is. Now, I have the amp set, all the volumes are down, it's just sitting there idling, no draw, no extra current being drawn, and I've already made a few measurements, so here they are here. Oops, sorry about that terrible flicker. So as we can see, the right side of the amp had a measurement of 36.6 ohms, and the right side of the transformer was 34.3 ohms. The voltage drops across those two are 1.82 and 1.12 volts respectively, and the plate voltage was 403 on the left and 402 on the right. You can see there's a slight difference in the plate voltages because of the resistance that voltage has to travel through to get to the plates, and our bias is currently sitting at minus 45.6 volts. So I'm just going to do a little bit of math and we'll work out the current. Some people don't really like to use this method because it doesn't take account of any screen current that's flowing, and while that is strictly true, the screen current is pretty minimal. It's usually in the order of a couple of milliamps, so you can pretty easily add a couple of milliamps to guesstimate your end result is pretty accurate. I've always found this method to work great, and it's certainly given me the most consistent results. Other people like to break into the cathode connection to ground and put like say a 1 ohm resistor in there and then measure the voltage drop across that. And while that is technically more accurate because it takes into account all sources of current draw through the tube, because they basically all have to return to ground through the cathode, so you'll have your plate current, any screen current, and it's not really relevant in this case, but in some amplifiers and transmitters and the like, you may have grid current. So but hey, this is a guitar amp. It's not a super duper hi-fi amp or a high wattage transmitter or some other fancy thing. So we're going to go with the transformer resistance measurement method, and like I say, it's always worked perfectly. We're going to aim to go for about 70% of the plate dissipation maximum on the output tubes. Now bear in mind that the output tubes in this amp are arranged in push-pull configuration with two pairs of tubes. So the final current that we get for each side needs to be divided in half to work out the correct current for each tube. Or we could simply take it and that, you know, it is a multiple of 2 So without further ado, I'm going to pause the video here and work out what those currents are, and I'll bring you right back. Okay, so after doing some calculations and some measurements, we can see that the two resistances of either side of the primary on the output transformer are 36.6 and 34.3 ohms respectively. The voltage drops are 2.14 and 1.4. On one side we have 426 volts DC on the tube plate, and on the other side we've got 430. So that corresponds to plate currents of 58.4 and 40.8 milliamps respectively. If we work out the power dissipation that induces in the tubes, that is 24.8 watts on the left and 17.5 watts on the right. Now we have to bear in mind that those are for two tubes, so we need to actually divide that in half to get the figure per tube. So we're looking at about a little over 12.4 watts on the left and about 8.5 watts on the right per tube. Now a 606 GC has a maximum allowable plate dissipation of 30 watts. We want to take roughly 70% of that, which is just a little over 20 watts. So as you can see, this amp is actually biased really cold. It's definitely in need of warming up. It will probably sound quite dry and tight and anemic the way it's biased now. So being a fixed bias amp, we need to go in there and measure some resistor values and see what it is we can do to warm it up a bit. I will do that now, and I will bring you back when I've figured out exactly what we're going to do. So after messing around for a little while with this bias voltage, trying to get the dissipation on both sides correct, it took a little bit of messing about, but finally got there. So I was finding that the set of tubes in this amp were not drawing equal current, which is not really a problem, and they will probably settle down as they're pretty new. So in order to equalize things, what I've done is clip in a resistance box across this resistor in the bias feeder network. So essentially I can now manually alter the bias. And what I did then is the same measurement as we did before. Oops, that's just the meter turning off. To work out the different dissipations. So with dropping 3.3 volts across each half of the primary winding of the output transformer, and the plate voltage is then dropped to 428 volts, that essentially ends up equaling a plate dissipation of 19.2 watts on the left and 20 watts per tube on the right, which is pretty much bang on, 21 being 70%, so this is like 68% or so, which is absolutely fine. That'll help tube longevity a little bit too. So the original resistor, that one right there in the middle, was originally a 3K3, and it hasn't really drifted, but in order to get the bias voltage correct, to get the proper tube dissipation, we have it hooked up to the resistance substitution box, so I can dial in a resistance, and in this case it ended up being 6K8. So essentially we need to pretty much double the original resistor value, and that's no problem, that'll work just great. So I just need to find a resistor of that value, pop it in there, and then the pot here, this is our tube balancing pot. So basically this divides the bias voltage between the left and right pairs of tubes. So I've just adjusted that to provide an equal voltage drop on each side, or as near as possible. I think it's about 0.8 of a watt in the difference, which is absolutely nothing in terms of a guitar amp. You know, we're really chasing a few watts here rather than going hard out to get the thing absolutely perfectly balanced like you would in, for example, a high-end hi-fi amp or something like that. So we're almost there. We just need to tidy this up now and find the correct resistor, solder that in. Then we are pretty much sorted in here, and we can move on to working on the cabinet. After a fair bit of trial and error, we finally got the bias voltage set, I believe, just right. So there, in that little bit of heat shrink you can see going across, we have the new bias resistor in there. So I had to parallel up a couple because it ended up being an odd value. I think it was about 7K1 or 7K2, something like that. But that's all right. We then balanced the output tubes using this pot. So as you can see here, I've got one probe on the right hand tube plates, another probe on the left hand tube plates, and I'm also measuring, I am measuring the voltage drop across both sides of the output transformer. So if we go across to the meters, so a little hard to get both of these in, I do apologize for the messy setup. You can see on the right hand side we've got 3.38 volts of a voltage drop, and on the left we've got 3.35, so that's pretty evenly balanced. And you can see it does bounce around a little bit. That's due to other appliances on the same mains line being switched on and off, and little variations in the mains voltage. So that's a pretty damn good balance we've got there. So I'm pretty happy with that. It equates to about 19 to 20 watts per tube, and yeah, that's good. It's a warm but not hot bias, so the amp should be quite lively, hopefully, and sound pretty good. We're just going to do a little output power test on the amp now and see how it's working. So I have the master volume up to 10. I'm going to bring up the channel volume and let's see what we get. And there's clipping, so we'll back it off a little bit. So we've got 50 volts. Let's say 48 volts for the sake of it. So 48 volts across a 4 ohm dummy load. That is almost exactly 135 watts. So yep, Fender are telling the truth. When it's a 135 watt amplifier, it actually is. That's cool. Well, after a struggle worthy of Sisyphus himself, I finally got all the knobs off the amp. Believe me, they did not want to come off. They were seriously well stuck on there. But having got that off, I then removed the control panel and gave it a good clean, and here it is. Look at that. Absolutely flawless. Perfect. So that will look absolutely beautiful now when we get that back on the amp. So I'm just going to quickly clean up around some of these pots and the switches just to get this all nice. I'll put the control panel on, I'll give the knobs a really good clean and some hot soapy water, get them back on the amplifier, and I'll bring you back then. And just a quick shot of the finished control panel. So we'll start here at the normal channel and move along. All the knobs are cleaned with hot soapy water and a good scrub. They've come up really nice. Cleaned the corrosion off the input jacks. All the knobs are in really good shape. And there you have it. Looking really nice and smart. So next job is to get the cabinet up on the bench, start working on that. I've relocated now over to the other side of the workshop where we're going to do some work on the cabinet for the amplifier. So this is the grill cloth, and you can see that the actual cloth itself is in really excellent condition. There's really nothing wrong with that. There's no holes in it, or tears, or stretched bits, or anything like that. Could possibly do with a slight bit of a clean, but that's neither here nor there. And we can see that the Fender logo is present and correct. So you're asking, well, what's the story of this? Why can't we just put this back on the amp? Well, let me turn it over and I'll show you. So this is the back, and this is the frame that holds the grill cloth. And if I show you here, as you can see, it's just disintegrating. It's made of this particle board, which basically is so soft that it just disintegrates. And we can see it's also just fallen apart here. And it's so soft, you can just pick it apart with your hands, really. It's also pretty much destroyed in behind where the logo goes here. So what I'm going to do now is actually remove the grill cloth and the logo, and I'm going to use this, or what's left of it, as a template to make a new frame. But instead of using rubbishy particle board like this, we're going to go fancy and we're going to use some plywood, and that will be way stronger and it will last forever. So the first thing I'm going to do is look along the edge and try and see how this is attached. It's usually stapled. I hope it's not glued. It may be. No, it's stapled. I can see the staples there. Okay, so I'm going to take a knife to this, and I'm going to pry this cloth off, and I'll bring you back when I've done that. Well, that was an absolute cunning stunt to do. Wow, those staples were in good, and there was just a whole warehouse full of them in there. But the cloth is off, and here it is. It does have one little blemish there, but I think we can make that pretty good. So we're going to put that to the side. We don't need to do anything with that for the moment. And this is the frame that we have to work with. So as you can see, it's in several parts. There we go. I'll measure that up, transcribe it out onto a piece of plywood, cut it out, paint it black, and set about putting the cloth back on. Hopefully it's a bit easier to put on than it was to take off. Now that the grill cloth is done and out of the way, it's time to turn our attention to the rest of the cabinet. So, in checking out this amplifier, it turns out that one of the speakers is not working. I don't know whether it's got a blown voice coil or a bad connection. We're going to take it out of the cabinet, check it out, and hopefully we can fix it. It would be good to be able to get that to work without having to either recone it or replace the voice coil. We'll also just tidy up inside the cabinet a bit, clean up that reverb tank, make sure it's working properly, clean up the back of the speakers, and generally give it a bit of a clean and a dust out. And it also, as I mentioned earlier in the video, this amp was missing its back upper cover. Turns out that the customer does actually have that, so no worries there. Alright, let's get the speaker out and hopefully we can make it work. After poking around for a little while trying to find out why this drive unit is not working, I have discovered that, if I can turn it around here, you may be able to see it, where the lead out wires come out into the cone. I've had to excavate through the sort of tar-like covering that they put on there, and you might be able to just see there at the end of the probe there's a tiny little bit of the aluminium voice coil wire poking out, and there's no way that I'm going to be able to join onto that. The lead out wires on this amp have basically rotted from here up to here, so yeah, this speaker needs a new voice coil, and unfortunately I don't have one of those. So what I'm going to do is send it down to a place I know that can do it, and yeah, it's a little bit disappointing. I suppose one thing that needs to be repaired out of the whole rest of the amp is not too bad going. So while that's being done, we'll carry on with getting the rest of the cabinet sorted out. So here it is, finally, the finished product. All nice and cleaned up and working just great. So you can see we've got that control panel looking pretty good overall. And of course the refitted grill cloth came out pretty good. It's not absolutely perfect, but for a refitted cloth it's not too bad at all. Moving around, we have the rear of the amp. You can see one of the speakers has been removed. It's actually gone out for a voice coil repair. So that will be back soon. You can see we've got some tubes in there, nice and shiny. Speaker leads, reverb, tremolo, or vibrato as they call it. Foot pedal leads and so on. There's our foot pedal down in there. Mains cable. And you can see the reverb tank down the bottom. So this has all been cleaned up and ready to go. So the next thing I'm going to do is get a guitar, plug it in, and well, we'll see how it sounds.